This video is on absolute value equations. We're going to be looking at absolute value equations and how they are graphed and how we can graph them without the use of a calculator by understanding that the function notation gives us our transformations of the original. So some information you need to know is the A value. The A value still tells you if it's a reflection or if it's a vertical stretch or compress, but it is also the slope. A is the slope of the absolute value function. Now, when you use your slope, the thing is that it's going to go in two different directions. When you do your slope, you go from your vertex. So it's from the vertex. And we're going to count from the vertex, and we're going to make sure we go towards the right-hand side. So to the right. So from the vertex to the right. The H and K is still going to give us our vertex, our vertical and a horizontal movement from 0, 0. And absolute value equations are similar to quadratics in the sense that it will go in two directions, but you are actually forming two lines. So absolute value graphs will form lines, not curves, lines that will meet at the vertex. So meeting at the vertex. That's why we need to know the slope needs to go from the vertex, and you're either going to go up and to the right or down and to the right, because the other side, we're just going to mirror those coordinates, or you can go, you're going to go to the left, and then you're either going to go down or left and up, depending on which direction your first line goes. So if you look at this example, we want to know, since this is f of x is equal to the absolute value of x, the parent function would have the vertex at 0, 0, because the absolute value of 0 is equal to 0. So then when we look at other values, let's say the x value of 1 and the x value of 2, we can also look at the x value of -1 and -2. We want to know what those y values will be. So if I take the absolute value of -2, we get a +2. Because remember, absolute value just means it's the distance from 0. -2 is still only 2 steps away from 0. -1 is only 1 step away from 0. The absolute value cannot give you a negative answer. Now, if there is a negative outside of it, or I'm subtracting something, then my y values could become negative. But the absolute value itself must give you a positive value, because distance is never negative. The absolute value of 1 is 1, and the absolute value of 2 is 2. So we have coordinates that we can graph. So our x and our y axis, we have a -2, +2, a -1, +1, 0, 0, 1, 1, and 2, 2. Now, this is our vertex. So our slope here, our A value is 1. So our slope would be from the vertex towards the right. We would go up 1, right 1, up 1, right 1. We'd continue to go on, because the absolute value of 3 is also 3. Absolute value of 4 is 4, 5 is 5, 6 is 6. If I did it the other way, I would go in the same direction, either up or down, but I would go towards the left. So I'm going to go, I have to go up 1, but now left 1. Up 1, left 1. Up 1, left 1. Up 1, left 1. Because the absolute value of -4 is a +4. So this would be our graph. We can find the coordinates and then just plot those. But if you know your vertex and you know your A value, then you can use your slope to plot those coordinates. So what we want to look at is to understand what your A, H, and K are and how it still affects It still affects the way that the graph looks and the way the graph moves. So on this function right here, f of x equals negative absolute value of x plus 1. Our a value is a negative, but our a value is also equal to a positive, it's also equal to a 1. So that will tell you if it's going to be a stretch or compress. Our h value, again, it's x minus h, so it has to be x minus a negative 1. So h is actually a negative 1, but your k value on the outside is 0, because that tells us if it opens up or down and what our vertex will be. So our vertex for this one is our h comma k, so it's going to be that negative 1 comma 0, and it's going to open down because our a is negative. But we want to know if it's going to be narrower, wider, or the same as the parent function. So since that a value was still a 1, the parent function a value is a 1, it will be the same width. So it's going to have that same slope, just going in the opposite direction. On this next one, our a value is again a negative. Our h value inside the absolute value, it has nothing with it, so our h value is 0. And our k value is on the outside, it's that positive 5. So our vertex will be that 0, 5, and since the a is negative, it's going to reflect over the x-axis, so it's going to open down. And then we look to see if it's going to be narrower, wider, or the same. So narrower is that vertical stretch, wider is that vertical compress, and the same means nothing happened to it. So the a value, the number, would be a 1 because it's going to be a negative 1. The parent function always has a positive 1, so the 1 value tells us that it's going to actually have the same slope. It's not going to be compressed or stretched. On this next one, our a value is a positive. It's actually a positive 3/4. Our h value is, again, it's going to be that a p minus h. So that h value has to be a negative 3. And then our k value has to be the outside, which is that negative 6. So our vertex will be that negative 3 to negative 6. The a value was a positive, so it will open up, so it's not going to reflect. But now we look at narrower, wider, or the same. That's that number of your a. So over here, they were all still 1s, but now the a value has changed. This a value is smaller than 1, so it will be a vertical compress, which actually makes it go wider because it's going to be pushing down the y values instead of trying to push them up and make them go faster. So it'll be wider than the original. So our slope would be, you'd go up 3 and then over 4 instead of up 3 and over 3. So it would actually be towards the right more. So we're going to graph these absolute value functions, and again, we're going to use our transformations to help us. So the transformations, we want to know our a, h, and k. So a is going to be a negative value. That tells us it's reflected over the x-axis. Our h is going to be that the x minus h, so x minus a negative 3. Our k value will be that positive 5 on the outside. So for the vertex and transformations, we can write this down. Our vertex is that h and k, so negative 3, 5. The transformations come from these three things. So we have a negative, that's a reflect over the x-axis. Our h was negative 3, so that's actually moving it left 3 from the 0, 0. Then we want to move it up 5 because that k value is 5. So we have our vertex and our transformations so that we can graph it without the use of a calculator. And we can still look at it in a calculator. So on our graph, we're going to have x and y axis. We already have our scale. So we have a negative 3, 5 is our vertex. So we're going to put our coordinate there first. And then from here, we use our slope. Okay, we're always going to go to the right side first. Our slope, I'm going to write that down, is that a value. So our slope is actually equal to a negative 1 because a value is negative 1. So negative means we got to go down. So we're going to go down 1, but then we have to go to the right 1. Down 1, right 1, down 1, right 1. And we keep going. The thing is that we are creating a line, but we're technically creating an array because I cannot go back to here and go up because this is my vertex. This is the farthest it will go up. So when I create my line, I have to start it at that vertex and just connect the points the other direction. Because now I need to go in the other direction. I'm still going to go down because this went down 1 and then right 1. Now I have to mirror that. I have to go down but left. So down 1, left 1. All the way down. Because these are two lines that will form a vertex. So it's forming an angle, and it is, they are going to actually be perpendicular to each other. So this is our graph where it is, our vertex is our stopping point. So that means that we cannot go above that vertex since it's opening down. So this is different than graphing just two lines. We have to make sure we can see that vertex. Now to show you this in the calculator, I'm going to turn my calculator on. I'm going to go to my y equals. I have a negative. Now I want to find the absolute value button. So I actually go to the math button here because if I don't know where something is, I should go to the math. I want to go over to number. The first thing says ABS. That's your absolute values. Newer calculator software will have the absolute value symbols that when you press it. Older software will continue to say ABS parentheses. You have to make sure that when you're done with your absolute value, you close your parentheses. This is a newer type of software, so I actually have the absolute value bars. So this will actually, I'll know when to stop it. So I'll press X plus 3. Then I need to get out of the absolute value bars by pressing to the right. And then I can put plus 5. I'm going to go to Zoom Standard just in case. And this is the same graph that we just had. So again, the math button is where you find your absolute value. So you go to number, and absolute value is the first one. Again, some calculators will actually still say, when you have it in your y equals, it'll say y equals ABS parentheses. So then when you put in your X plus 3 or something, you have to make sure you close your parentheses to end your absolute values. So this next example, again, we're going to do it without a calculator. The A is a positive 2. The H is going to be a negative 1. And our K is also a negative 1 from the outside. So our vertex is at negative 1, negative 1. The transformation, since our A value is bigger than 1, this is going to be a vertical stretch of 2. Because the stretch is bigger than 1, and it's of 2. We're going to go left 1, then we're going to go down 1 from our H and our K. We also, again, want to know what our slope is because that will help us if we don't have a graph. Because, again, these are basically lines that are forming, or you can, technically they're rays. So on here, your slope is equal to a positive 2. So all right, we have our x and our y axis. We're going to go to our vertex of negative 1, negative 1. And then from this coordinate, we have to go, since it's going up, we have to go up 2. And then we have to go to the right. Because our slope is 2, we have to go up 2 and to the right. We always have to go to the right first. So up 2, right 1, because our slope is 2 over 1. We're going to keep doing that, up 2, right 1. But we can only go in that direction. So when we connect our points, we're forming a ray that will stop at our vertex. Now we're going to go in the opposite direction. meaning we're going to mirror it. So we're making it perpendicular. Well, not perpendicular, but we're going to go up 2, but then left 1, because we have to go in the same direction, either up or down, but then we have to go to the other side. So we're going to go up 2, left 1. We're going to keep doing that. Up 2, left 1. Then we're going to connect our points, and again, we're going to stop at that vertex, because that vertex is where it must stop. And that is our graph of the absolute values. On these two, we're going to use the graphs to write the vertex and the absolute value functions. So as long as we know our vertex and our slope, we have our a, h, and k. We don't have to solve out for the a. We will automatically have it. So on here, we need to find our vertex. Our vertex is the point where it stops. Our vertex is at +2, +3. And then we need to find our slope. Now remember, our slope has to start from our vertex, but it has to go towards the right. So in order for us to get our slope, we want to find a point on the right to go to. So we go to here. So I would have to go down 2 and then right 1. So down 2 would be -2, and right 1 would be a +1. So our slope is -2. That means our equation will be written as y equals, our a value is -2. We'll have our absolute values of x minus the h value, so minus that 2 absolute value, plus the k, so +3. You might also see it as f of x is equal to -2 absolute value times of x minus 2 plus 3. So either one of those mean the same thing. F of x and y, they mean the same thing. So that's our equation. And then you can graph it to see if those coordinates match. So this next example, we're going to do the same thing. We need to find our vertex first. So our vertex is at -1, +2. Then we need to find our slope. So again, we need to find a coordinate on the right-hand side to go to. So it looks like this is a good coordinate because it's at the corner. So we had to go up 1 and right 1. So that's a +1 over a +1. So our slope is just 1. So we can write our equation as y equals, our a value is 1, so I'm going to put a 1 there. Absolute value of x minus h, that'll become +1 absolute value, then plus k, so it's going to be +2. Now when I write it as, I can write it as an f of x equals, since our a value is 1, we don't have to write the 1, so, because if there's nothing there, it is a 1, so I have the absolute value of x plus 1, absolute value, plus 2. I will say on the absolute values, especially when you have number 1s or anything that starts with a 1, like a 10 or 13, you want to kind of over-exaggerate your absolute values so you know that they are absolute values and not a 1. Because sometimes if you're not paying attention, you'll think that you wrote your 12, but you really just wrote a 2. So absolute values, as long as you can find your vertex and you find your slope going towards the right, then you'll have your a value and you'll be able to write your equation.